Okay, we are discussing resource management. We already discussed human resource and how to calculate them. We are discussing the non-human resources, and these are material, equipment, tools, and so on and so forth. And last time we looked at some general discussion. Okay, the problems which we can face like downtime, idle time, proper management, okay, and balance between labor and equipment cost. When you try to reduce one, you may increase the other one, and the distribution, okay. And we finished at the discussion of why rental or ownership, what are the benefits of rental versus ownership, okay. And you did it in the groups, but these are some of the factors which are already mentioned in the slides. So in ownership, you have to pay the cost upfront, and that is a large cost as compared to rental. In rental, you are paying as much as you use. Maintenance is owner's responsibility, and in the the rental company will take care of the maintenance. And but in ownership, you get more flexibility. So if I want to use the equipment from any day or night or any time, it is totally under my control. But in rental, the flexibility is you know, yeah, if you okay, the flexibility in terms of time is limited for rental, but flexibility in terms of scaling, like the how big machine you want, okay, that is that can be changed for rental. Okay, so in one project I need a small excavator, and the other project I need a big excavator, so I don't have to think about whether I should use it or not. Okay, I will rent a bigger one. But in ownership, obviously you have what you have. Okay, if you have a small one, you will try to use it. Okay, so in terms of time, the ownership will give you greater flexibility, but in terms of size, you get more flexibility when you're renting the equipment. Okay, the equipment can be charged to the client on hourly basis, and this is very common if you are taking the rental equipment, because you are paying yourself on hourly basis to the rental company. So it's easier for you to bill the client for on the same basis. You can, if the project is longer, then this can be daily, weekly, or monthly rates as well. So I need a what you call a dumping truck for 2 weeks. Okay, so then the rate can be per day or per week or something like this. If you are owning the equipment, then the last two options are much better for you. You tell the client, I will bring my own equipment and you give me this much cost in addition to what we are already paying me for my work. Okay, or you can say, okay, for the equipment, this much is the cost, and I will take 10%, 20% extra profit margin on the cost of the equipment. But so in the last two options, you are telling the client that this is the cost of my work and this is the cost of my equipment. Okay, and then on the top of that, you may ask for some extra benefit because you are bringing your own equipment. Okay, in the last option, but the last two cases are much more beneficial if you already own the equipment, because you cannot commit to the cost if you are renting the equipment. The rental company may give you a different cost. Okay, so it's risky if you are renting the equipment and going for the last two options. Okay, because you cannot fix the cost in that case, you're like from your side. Okay, choice of equipment depends upon many things. Okay, the main thing is which equipment best suits my site. Okay, which particular equipment is the best suitable for my site. Okay, the size of the site, the type of the site, the type of project, all these things are considered part of the site conditions. Okay, so you look at the site condition, then you select the site. Okay, so couple of examples are given. This one is for an excavator. Okay, so an excavator, you will look at what is the size of the job, meaning total amount of material to be excavated. If total amount of material, excavation material is higher, you will go for a bigger excavator, and vice versa. Activity time constraints. In some cases, you may have a small quantity of material, but you have to finish it fast. Okay. So in that case, you may go for a bigger excavator even for small quantities because you want to finish it fast. Availability of the equipment. Okay. And this can be a problem for rental as well as ownership. For ownership, for sure. Okay, you will look at what size of the equipment and excavator you have. But even for rental, let's say I am taking equipment from a particular company, and that company doesn't have a very small excavator. Okay, so I will try to avoid taking a chance with a new company for renting the equipment. Okay, this is usually people avoid because this is risky. So we try to go even if you are renting it, if you are subcontracting it, we try to go with the people who are already working with us. Okay, this is safer. So in those cases, then obviously the rental company may still have a particular range of equipment. Okay, so availability of the equipment can be a point or an issue for ownership as well as rental equipment. Cost of transportation of the equipment. So the equipment I need is coming from where? Okay, again, it could be there could be a case where I have the equipment, but right now it is working on a project in Saudi Arabia. Okay, so I want to bring it here. Okay, so I have to, you have the toll and you have the permission and everything. Okay, so from where you are bringing the equipment? If you are going to buy a new one for this project because you feel you will use it in the future as well, this can be then the lead time could be even higher. Okay, the equipment you have to buy it, then the company has to ship it, and then the shipping can take weeks or months. Okay, and then it comes to the customs and you need the approvers and it sits there for 2-3 days until you get all the clearances and so on and so forth. So from where you are bringing the equipment and how much it will cost you. Okay, so cost in terms of money as well as time. What type of soil you are going to excavate? So remember, this is an example for an excavator. Okay, so the type of soil. Okay, for loose soil, the excavator could be different. For hard soil, hard rock, obviously the excavator will be different. Okay, and you may need to do some drilling or something else before you do the excavation. Geometric characteristics of the elements, the size, basically the size and the orientation of the site. Okay, is it a square type of a site or it is like an irregular shape? Okay, so for example, if I have a site like this, it's easier to excavate. Okay, but if I have a size like this, okay, so then your choice can differ. Okay, you may want to do it half manually as well in this case. Okay, so we are talking about the orientation of the site. The space constraints, so you need a bigger equipment, but the site is small. Okay, so that big excavator will not even fit into the plot and work freely. Okay, characteristics of the haul units, the trucks which you are using for disposing the material. Okay, this can be a problem as well. Location of dumping areas, so where are you going to dump the material? Okay, so if the dumping site is far, you may try to do more excavation in one trip and so on and so forth. The weather and temperature conditions, okay, some equipment are not good to be used in high temperatures. Some equipments may not be good for areas which have more rainfall and so on and so forth, because it will change the type of soil. Basically, the weather and temperature can change the type of soil as well. Okay, so these are some points for the excavator, and then we have some points for the another. Okay, so these are just examples. Obviously we cannot cover all the possible equipments, so just few examples to open up your minds. Okay, so the hauler is something like this. Okay, So you have an open cabin at the back, an open unit at the back where you can easily load the material and you can dump it. Okay, so this back cabin can tilt and then it can dump the material easily and so on and so forth. So if you are going to select the type of hauler, okay, so we want to uh, select the type of hauler which can expedite the work. It can do it quickly and efficiently, right? And it can minimize the idle time, the time for which the equipment will remain idle on the site or on the dumping site. So what characteristics we need to consider on a hauler is taking the material which you are excavating. So the selection of hauler will depend upon the selection of excavator. A bigger excavator is carrying or excavating more material in a given time, so you need a bigger hauler as well. Okay, distance to the dumping site because of the speed. Okay, and from what roads it will go and so on and so forth. The volume of excavated material. Okay, already mentioned that. Okay, and it may happen that you may decide that okay, I will bring one hauler because I have a storage space on the site. So while the hauler is taking one trip to the dumping site, I will put the extra material, extra excavated material on that particular part of the site. Okay, so if I have some space like this, if I don't have any space to keep the material while the hauler is loading and dumping, then the excavator and the hauler should be of the same size, right? We have the material excavated, should it will go directly into the hauler. Okay, the space and the weight requirements, the same thing which I talked about for excavator as well. Okay, so you want a bigger hauler because you have more material, but the size of the site is small. Okay, now you may ask that if the size is small, why I have more material? Okay, and this could be because you are going deeper. So it's a small site, but the excavation is deeper. So in that case, the quantity of material may it still increase. Okay, so now what about the weight? Why are we considering the weight constraint? Why the weight is written here? Okay, space we understand. Okay, the hauler has to come and park, and so we have to see if I have enough space to have this size of the hauler. But what about the weight of the hauler? Why I am considering the weight? Okay, even for the excavator, the weight must be considered. Okay, so why weight of excavator or hauler is important for selection? They are on the ground basically. Okay, the hauler and the excavator are basically on the ground, so I'm not talking about lifting them or something. So why would I consider the weight in this case? Yes, anyone has any idea? Take a guess. Okay, so all of you have pretty much the same idea, which is correct. Yes. The site is still uncompacted. It is still being excavated. The hauler has its own weight, so it may cause settlement or it may cause a collapse. Okay, so you have uh, the excavation done. Okay, so the excavation is something like this, and you have the hauler standing here. So if the weight is too much, the site may collapse. Okay, so your whole excavation may go down the drain. Okay, so that's why the weight is important. Yes, so good. Usually we don't use a specific hauler, something like this. We use a normal truck. Okay, the normal enclosed truck which you see for furniture and which you see for anything, and they just use it because it's multi-purpose. Okay, and compared to the hauler, the truck is much more faster as well, because you can look at the tires of the hauler, and another thing, it's open completely. So in comparison to that, a truck is much more efficient on the highways. Okay, and it is easier to manage on the site as well. It can turn easier than haulers. Okay, so they normally, all the companies have their own trucks which they can use for many things, so they just use it for the hauling and dumping as well. Okay, so how do we calculate the capacity of the equipment, and how do we find out the number of equipments required for a site or for a job? The top part is usually something which you can, the top part is, you can remove it. Okay, it's not fully enclosed, like for dumping it's not fully enclosed, but the top part is something which they can, remove and then put back. Obviously they don't do it for every hour and every day. Okay, so normally they keep it open most of the times, but it's a normal truck which you have seen. Okay, so it's not like an hauler, it's not like a hauler. Okay, so it's more close to the trucks which you normally see, but they remove the top part because most of the time they need it open. Okay, so yes, good point. So now there are three important parameters when you are calculating the capacity of an equipment and the number of equipment for a job or for a site. These are cycle capacity. So in one go, in one series of actions, how many units of product the equipment can handle. This is called as cycle capacity. Okay, so when the equipment finishes its function for one time, how many output units it can give you, or how many output units it can handle. This is called as cycle capacity. Okay, so if you use the equipment 2 times, you will get twice of the output. If you use it 3 times, you will get 3 times the output, and so on and so forth. So the output which you can get in one function of the equipment, one complete function of the equipment, is called as cycle capacity. The time to finish that one function once is called as cycle time. Okay, the time to finish the full function of the equipment for one time is called as cycle time, T. So if you want to calculate the rate of production for the equipment, it will be capacity upon time, right? The rate is capacity upon time. R equals to C upon T. Okay, and if you want to calculate how much time the equipment will require to handle C amount of material, then you will do this thing. Okay, so capacity upon the rate. Okay, so this will give you, if you want to handle this much capacity, then how much time you need. Okay, so obviously this whole thing is for one cycle. Okay, this whole thing is for one cycle, but you will not use the equipment for one cycle, right? You will use it for the full day. Okay, so let's say in one day you are working for H hours. Okay, so H is the number of hours which you are working or you are using the equipment in one day. So your rate is R, okay, per unit time. It can give you this much material or this much output, and you multiply with the number of hours you have. Okay, so this will give you the total production of the equipment in one day. Okay, obviously you can change the time units. You can change the hours to days, so it will give you the production for the whole week or the whole month. Okay, so this is up to you. So PE is the production rate of any equipment. Okay, let's say it's an excavator. So excavator is giving you per unit or per hour this much quantity. Okay, you multiply with the number of hours you are using the excavator. This will give you total production of the excavator. Okay, and so on and so forth. And then this is for hauler. Okay, again these are just couple of examples just to give an idea. Okay, for the purpose of the class we will keep it up to the equipments which we are discussing, but in the field obviously you should know that you will have more equipments, and these concepts will be applied to those as well. Okay, now hauler is something which is depending upon excavator. Okay, I already mentioned it. Okay, so you excavate, you put it in the hauler, and it will go and dump and come back. Okay, so the hauler has three times: time to load, time to go to the dumping site and come back, travel time, and the time to dump the material. Okay, so there is loading time, then there is the travel time, and then there is the dumping time. Okay, it will need some time to dump the material, whatever, maybe 1 minute, 2 minutes, whatever it is, but it is time. Okay, we are talking about repetitive actions. Okay, so this 1 minute for one cycle, for the whole project it could be in hours, so that's why we have to consider all these things. So how do you calculate the travel time? You have to find out the speed of the hauler, which is s, and you should know the average speed. Obviously we know that the hauler will not go from point A to point B with a constant speed, so average speed of the whole trip, and the distance from the site to the dumping site, from your construction site to the dumping site. So let's say that that distance is d, so the hauler will go and then come back, so 2 times d, and it will do it at a speed of s. Okay, so 2d upon s gives you the travel time of the hauler. Okay, 2d upon s gives you the travel time of the hauler. Okay, and then we have the loading time. T naught is the loading time. Okay, now loading depends upon excavation. Okay, how quickly the excavation is happening. Okay, so excavation, so we want to fill the hauler completely, right? Before we move the hauler, we want to fill it. So the capacity of the hauler is ch. Okay, capacity of the hauler is ch. In how much time it will fill, it will depend upon the rate of the excavation. Okay, so it is basically T upon C will give you how many hours per unit material you are taking. Okay, time per cubic material. Okay, and then you multiply with the capacity of the hauler. So it is basically, let me write it here, TE upon CE. This will give you the time per unit material excavation multiplied by the capacity of the hauler. Okay, so time per unit material multiplied by the material you need to fill. Okay, so this will give you the time which the hauler requires to load. So it is depending upon the time required by the excavator to dig that material, to excavate that much material which will fill the hauler. So if the hauler requires 3 cubic meters of material and the excavator takes 2 hours to fill, excavator takes 2 hours to excavate 3 cubic meters, then this is the time which the hauler requires to fill. Okay, usually they excavate and directly put it in the hauler, they don't store. Okay, but if there is a storage time, then the story will be different. Okay, so this is a simpler case, the normal case, the most common case, where excavation is done and directly put in the hauler, direct. Okay, so we have 3 times: the travel time, the loading time, and the dumping time. The total time of the hauler for one cycle is travel time, loading time, dumping time. Okay, 3 times. And if you want to calculate the productivity of the hauler, okay, so hauler capacity upon time will give you rate of the hauler. So hauler capacity we can know from the size of the hauler, and time will come from here. Okay, total time required for one cycle of the hauler. So capacity upon time will give you rate multiplied by the number of hours for which you can use the hauler. Okay, now in this case we are not including any idle time. In this whole calculation there is no idle time. So what is happening? the hauler comes to the site, excavator is working, it will fill the hauler, no time wasted, it will directly go to the dumping site, it will dump and straight away come back and again go into the work straight away. Okay, so there's no idle time here. If there's idle time, you can add a factor here. Okay, so I need like 10% extra time, or 20% extra time because the driver may take a break or something. Okay, so but this is like a theoretical function to calculate the productivity of the hauler. Okay, now we know that for the hauler, when you excavate the material, it is compacted material. Okay, the earth is naturally compacted. People are, moving over it and so on and so forth. But naturally, the material you are excavating is compacted. But when you fill it, it becomes loose material. Okay, so we know if I excavate 2 cubic meters of material in the truck, it will take more than 2 cubic meters because it is not compacted in the truck or the hauler, whatever you call it. Okay, so I should not calculate the number of haulers using the compacted rate. I should use the calculate the number of haulers using the loose material rate. Okay, so WPE, so PE is the compacted material and W is what they call as a swell factor. Okay, now can somebody remind me in which course you have seen this or used this W factor? You have used it. Okay, the swell factor, where did you use it? Materials, okay, okay. Where else? Soil mechanics, okay. You may have used it in quantity as well, and in highway I'm pretty sure that we have used this. Okay, so these are the courses in which, so you should be familiar with it now. Okay, so you are taking this much material which is compacted daily, excavating it. So this is the excavated productivity multiplied by the swell factor. So how much this will become when it goes into the truck in the loose form, and then you divide by how much is the productivity of the hauler for 1 day. Okay, so you get the number of haulers. So total material to be handled in 1 day, productivity of the hauler in 1 day, and you divide it and you get number of haulers for that site. Okay, and obviously you can say that, okay, I don't need this, I'll just bring one hauler and I will do it for multiple days. Okay, but that means your excavation has to be adjusted for that much time as well. Okay, so this is, remember, material excavated in 1 day, multiply by swell factor to get the actual quantity to be hauled in 1 day, divide by the productivity of the hauler for 1 day, you get number of haulers required for each day. Okay, so these are these are theoretical equations, but you have to keep in mind that practical work may not be that ideal. Okay, the work conditions may not be ideal. You need people will need breaks, and there could be problem with the site, there could be problem with the equipment. Okay, you may need to stop on a trip to refill the fuel and so on and so forth. So some of these things should be taken into account, and you may you may use some factor of safety. Okay, so we have an example here, a power shovel. So shovel is type of excavator, okay, which it works like this. So it has a crane like this, and it goes into the sand and takes the sand like this and so on and so forth. Okay, so it's like a hook. Okay, so that's called a shovel, and that shovel can excavate 1 cubic yard in one cycle, and that one cycle takes 30 seconds. Okay, so in one cycle of 30 seconds, it can excavate 1 cubic yard of material. Okay, and this shovel will be used for 8 hours on the site. Okay, so its cycling capacity, cycle capacity is 1 cubic yard, cycle time is 30 seconds, and it is available for 8 hours in one day. Okay, so if you want to calculate the production rate for a day for this power shovel, then 1 cubic yard upon 30 seconds, okay, will give you the rate RE. Okay, so RE is 1 cubic yard upon 30 seconds. Multiply by the number of hours it is available for the day, which is 8 hours. Okay, and this is because we have 30 seconds here and we have 8 hours here. So I need to convert the units. Okay, so this is 960 cubic yards. Now this is 960 cubic yards per what? How much time? So the power shovel will excavate 9 cubic yards of material in how many hours or how many days? Eight hours, okay, or one working day, whatever you want to call it. One working day or one or 8 hours. Okay. Okay. So then we have, if you want to charge the client, okay, then you may have to add some other things as well. For example, depreciation cost. Okay, so I told you earlier, depreciation cost, you may have studied about it in economics. So the cost, reduction in cost of the equipment because of the time. Okay, as the equipment gets older and older, there's a certain percentage of cost which is keeps on decreasing and decreasing. Okay, from the, so if I go and sell this equipment, I will not get the original cost, because even if the equipment is in the same condition, because of the time it has spent since its manufacturing, the cost is reduced. So the cost which is reduced only because of the time passed, that is the depreciation cost. Any maintenance which you may have to do during the project, okay, or overall maintenance, change of tires, change of oil, anything else, okay, cleaning and whatever. Fuel cost, obviously, operators will take a cost. Okay, so all these things are total for the whole project, and then you divide by the number of hours in which you will operate this equipment and your project. Okay, plus the profit margin. Okay, so total cost is 100 per hour. This total thing is 100 per hour. Okay, and you have 20% profit, so your total cost will be 120 per hour. Okay, so this is how the rental company will charge you as well. Okay, and so you don't have to like take profit on that, okay, because you are already renting it. But if it's your own equipment, you can calculate the cost like this. Well, for rental, obviously you have a fixed cost per hour. Okay, so then you don't need to do this whole thing. You are this whole thing is the cost which you are paying to the company. That's it. Okay. If the project is smaller, then you go for hourly rate. Okay, I already mentioned. Project is longer, then you go for daily and weekly rates. Okay, and going in this way will require less tracking, because if you go in more details of the cost, the tracking should be according to the time scale. Okay, so if I'm giving or billing the client per hour, then I need to show the client how many hours the equipment is used. If I'm billing the client for number of days or number of weeks, then I need to show how many days and weeks. So I don't need to show every hour. Okay, so the administration becomes simpler. Okay, if you are going for longer time intervals for billing. If you are going for fixed cost for the whole project, then obviously tracking becomes easier, and you don't need to fight or show the client how many days and how many hours the equipment was used. You just tell them, okay, you require the full excavation of the plot. I have done this. You can see the size, and this is my bill. That's it. Okay, and Same thing for the fourth option as well, but there is you will bill the client for the cost plus something else which is already in the contract. Okay, so for the fourth type, you are actually telling the client how much profit you are taking on the equipment work only. Okay, so this is the difference between the third and the fourth option. Okay, so in the third option, the equipment is part of your work. The total bill which you give to the client for your total work includes the equipment cost as well, and you are not taking any profit for the equipment itself. But in the fourth in the fourth option, you are billing the client separately, the profit separately to the client for the work which is done by the equipment. Okay, so for the whole project I'm taking this much, but for this phase, because I'm using my own equipment, I will charge you 10% extra just for from the equipment cost. Okay, so this can be done if you are a subcontractor, for example. Okay, so you are only dealing with the equipment only. Okay, so then you have to charge for the profit from the equipment work, or you are the contractor, but for most of the work the client himself is bringing the equipment. So there is only one activity where the client says, okay, you bring your own equipment. Then for that particular activity I may charge him some extra amount in terms of profit. Okay, so the fourth model goes there usually. Okay, so you can read this book for more. It's not an assignment, okay, just for your own thing. Okay, and you can, the most important thing will be in the book, you will see more examples, I believe. Okay, so please go ahead. I will recommend, because you have seen that we only covered couple of examples here. Okay, now we go towards the third item, which is cost estimation. So we have, it's not even third, is basically it's the fourth item. We covered scope. Okay, we covered scope, we covered time, resources. Now we are covering the cost. Okay, for the scope thing, we make some diagram or some chart to show the scope of work. What is that? Okay, what diagram or chart is used to show the scope of work? The total work which you have to do. What do we use to show that? Gantt chart, yes, very good. What about Gantt chart is for time? Sorry, got carried away. Gantt chart is for time. Gantt chart is used for time. WBS, yes, work breakdown structure. Yes, Gantt chart shows the scope of work as well, but WBS comes before. WBS comes before. Gantt chart is on the basis of WBS. Okay, so for time we have Gantt chart, and there was something else as well. Who can remember for time? What else was there for time? So we discussed the Gantt chart, and there was another diagram or another analysis which we did for the time management. What was that? CPM, okay, critical path method. Basically the diagram is called as activity on arrow or activity on node, AOA or AON. Okay, but yes, the method is called as CPM, and we discussed the PERT as well. And then in the resources, we did not discuss any diagram, but we have seen the productivity and how to calculate the cost and the number and so on and so forth. Okay, so what is cost estimation? It means that predicting the total cost of the entire construction project. Very important. You have already taken one course at least, and there were other courses in which you are talking about the cost. Okay, you must have talked about it in construction engineering. You have talked about it in highway engineering, and what else? I forgot. But you can think about it. Even in the economics course you were talking about the cost of the project. Okay, so there are certain economic elements which are involved in calculating the cost of the project. Okay, the key elements on the basis of which we calculate the cost: labor, materials. Labor means manpower. Labor doesn't only mean the people who are getting their hands dirty on the site. It means manpower. So even the site engineer, even the foreman, they can be considered part of the labor. Okay. The materials, equipment, overhead, and contingencies. Okay, we have discussed overhead before. What is part of overheads? Tell me. What are the overheads of a construction project? Yes. What do we mean by overheads and what is included in overheads? Office and salaries, equipment, shipment, okay, expenses, fuel. What is the most important overhead? Tell me. Yes. What is the most important overhead? It's not written here by these two guys. Anybody can guess? No one? They are part of they are not overheads. They are part of the labor and so on. Okay, the most important overhead is internet, right? Huh? Internet connection. Okay. So even the people on the side, they you have to like buy packages for them. So most important overhead, right? You cannot live without it. So moving on. Yes, but the other things you mentioned, site supervision is part of labor cost, manpower. Okay, but the overheads are these things: office rent, salaries, okay, any shipment cost, okay, fuel cost, they can be considered part of overheads. Okay, and any softwares you are using, any subscriptions, and blah blah blah. Okay, contingencies are events which may happen, so you want to keep an extra amount of cost for those events. Okay, these are called as contingencies. Okay, so if rain happens, then heavy rain happens, I need to cover the site and the concreting, and I have to stop the work, and I may need a pump to get the water out of the excavated pits. Okay, so it may happen, it may not happen. Okay, so how much cost I will take for this? So contingency is for unforeseen events which may or may not happen. Okay, so these are extra costs which you may or may not require. Okay, usually every project has this because we are not sure about the material pricing. For example, we may have some equipment downtime, equipment major maintenance, okay, which you may not know. Okay, so every project has some contingency cost associated with it. Okay, yeah, utilities, yes. Okay, so what is the importance of cost estimation? You need it is used in budgeting, and it is used in the bidding process as well, the contract, what do you call, when you are hiring the contractor, okay, the bidding process. So the contractor has to estimate the cost of the project, and they this is basically their what do you call, the competitive advantage, right? The one who gives the lowest cost considered good. Okay, for some reason, although it is not the correct approach, obviously, but this is considered as an advantage, right? If you give lower cost than the others, you are having some advantage over the others. Okay. Then it also helps you with your financial planning. So how much cost you will need for the whole project, and so you need to arrange it, right? Nobody, the client or the contractor may not have the full cost of the project in their hands from the start. Okay, and usually it happens on the construction projects that the money is rotating. Okay, the money keeps circulating, so I may get the money from one client and I may spend it on some other project. Okay, it is a very common phenomena, and for the client, obviously, this is the case. Okay, take the government, okay, the ministries. Okay, so they get their annual budget, and the project is, and they have to spend that annual budget on multiple things: the salaries, the office, the projects, and so on. So they have to arrange, they have to plan for it, they have to tell the government, okay, this much we will need, okay, at this time, because this project will be finishing and it will finish 50% of the work in this year. So you need the cost estimation for doing the planning as well. uh, so cost estimation is very important for selection of the project as well. So you may have, for example, you may have seen, and they are doing the new bridge at the Salmabad intersection. Okay, so before they started with this project, there were multiple options they were looking at. Okay, should we go for a bridge? Should we go for a 3-lane bridge? Should we go for an underpass? Okay, so they were looking at multiple options. So how do you select between these options? One of the most important criteria is the cost. Okay, which option will give us the lower cost? Okay, and in some cases the project may be totally cancelled because all the options are very expensive. Okay, so there are, there are many uh, intersections and roads in Bahrain where you feel that the problem is existing for so many years but nothing is being done. Okay, because it could be because, obviously, I don't have inside information, but it could be because all the options which are for that particular site, they are very costly. The land is not available, you have to buy the land and you have to move people and so on and so forth. So the required cost is a very important element of feasibility of the project, which project to go for, and in that project which option to go for. Okay, I already mentioned about securing the funding. So once you know the cost, I need this much money. Then it helps you with the tracking as well. You already have a target in your mind. Okay, so you assign this much cost to the project. Okay, when this project finishes, I will need this much money. Okay, so if I'm going over this money, that means something is going wrong, something is not going according to the plan. So a cost estimate helps you with the tracking of the project as well. And I already mentioned about feasibility. So feasibility is one of the types of decision making. I mentioned bidding. So bidding is what? Decision making. You are deciding which contractor to go for. Okay, so in all these cases, cost estimation is very important. Okay, so the estimates can be of different, the cost estimates can be of different types. And these are according to how much detail you are going into and phases of the project. Okay, so as you move along the project, as the project is moving forward, it is progressing, the cost estimation becomes more and more detailed. It becomes more and more uh, micro scale. Okay, you start looking at each and every detail of your project. Okay, So when you are at the early stages of your project, you are just brainstorming. Okay, if I start this project, how much cost I will need. Okay, so you are using your experience, you are using historical data when a 20-story building was built in the last 5 years. How much was the approximate budget? So here you are relying on experience and past data. You don't have the data of your own project yet. There is no design because you are at the conceptual stage. You are at the initial stage. You haven't started the design. You are just thinking, should I move forward or not? So I mentioned it earlier as well. At this stage, if you hire a consultant to do the design and to do the cost estimation, the cost estimate will be very accurate, but it could prove useless because based on the cost, you may decide I will not go for this project. Okay, so uh, the conceptual estimate is usually based on experience and past data of other projects. Okay, so the accuracy is usually higher. So 20-30% means around uh, 1/4 to 1/3 of the cost can be wrong. Okay, like the error can be about 1/4 of the cost. So if I'm saying 1 million, then 250,000 is the chance of an error. Okay, then we go on to the next stage, which is when the design is uh, you know starting up. Okay, so you have selected the site, you already have some specifications in your mind. Then I'm going to build these many stories, then I'm going to use this material mainly. Okay, so some specifications of the design are ready now, so your estimate becomes more accurate. So you can see the error becomes lesser. Okay, the error can be 10 to 20%. Okay, so this is after the conceptual stage. So now you have more details in your mind about the project, but these are general details, these are macro scale details. We do still don't have the full design yet. And then we have the next stage, which is the detailed estimate, and here the chance of error goes up to 10% or less because we have the full design and specifications ready. So this is where you have already employed the consultant, and the consultant has already given you, or the consultant has already done their job, and on the basis of their design specifications you come up with the cost estimate, which is very accurate, and this is the one which you will use for bidding for the contractors. This is the one which you will use. Okay, then we have the bidding estimate. Now the difference between the detailed estimate and the bid estimate is the person who is doing it. They are usually done at the same stage. Okay, they are usually done at the same stage, but the third one is done by the client or the consultant, and the fourth one is done by the contractor. Okay, now what can be the difference between detailed and bid estimate? They should be same, right? Theoretically they should be giving you the same values. So what are the possible things which can be different in both of them? There is one thing which is very obvious, which is what? Both of them have the specifications. You cannot contractor cannot do it without the design. Both of them are doing according to the design. No, no. Both are done before the selection, but one is done by the client or the consultant, and the other one is done by the contractor. So they are at the same stage. They are at the same stage. and both of them should have the same details. You cannot ask the contractor, okay, give me a detailed estimate for bidding, and don't show him the design. He cannot do it. Okay, even if he does it, then he can ask for extra cost in the end because you didn't show him the design. So they are at the same stage. The profit margin, yes. Okay, the most important thing will be the contractor will include his or her profit margin, the most important thing. Okay, anything else the contractor may do differently? So you have hit the jackpot with the profit margin thing, but is there anything different? Almost. Anybody else wants to add something here? No. So I will go further with what Faris is saying. The contractor uh, may add or subtract something on the basis of his or her own experience and methods. Okay, so the contractor may have a better knowledge of the market. He may have an alternative to the estimate or to the method or procedure which the client or the consultant was thinking about. So he may say, okay, I can do the same job but with less cost. Or you are asking for this specification and this material is not available in the local market. I have to bring it from somewhere. So it will cost you extra. Okay, so the contractor may use his or her own experience and knowledge of the market and of the construction methods to change the estimate. Okay, so this could be something which is different between the detailed estimate and the bid estimate. Okay, so the contractor can do this as well. Yeah, the contractor, the cost which is given by the contractor, and obviously you can discuss with the contractor. So if you are the client and you had an estimate, you gave the same design specification to the contractor and he gave you cost which was 20% less or 20% more. Okay, so you may ask the contractor to come and explain the differences. Okay, why are you asking for this thing more, why are you asking for this thing less than what we have estimated? So you should not go blindly. Okay, so these negotiations are usually done at the bidding stage. Okay, so even after selecting the contractor you can negotiate. Okay, that okay, I'm satisfied with the rest of the things, but why are you asking me more price for steel, let's say? Okay, why are you asking me more, or why your estimate for excavation is less than mine? Okay, we are not talking about like less than few hundred BDs. We're talking about like maybe a difference of 10, 20, 30%. Okay, so you can negotiate and you can ask the contractor for more explanation. Okay, but the point was between the third and the fourth type of estimates, the main difference is the perspective. Third one is from the perspective of client and the consultant. The next one is from the perspective of the contractor. Okay, and then we have the control estimate, in which you break down the cost further for each activity and for each item as well. Okay, so the bid estimate may show excavation cost this much. In the control stage, you may look for, okay, this was a total cost of excavation, from this much is for excavator, this much is for the operator, this much is for the fuel. So in the control stage, you can go for even smaller items as well, or people usually go for smaller items as well. Why? Because of tracking. Okay, you want to track the progress of the work. So I already spent 10,000 BD. Okay, I did not finish even the excavation. So where is the problem? Where did I spend this money? Okay, so then you have to go and look for small items as well. That the excavator was went to the garage because it was not working, and we've spent 6,000 BD only for the repair of the excavator and so on and so forth. So control estimates are more detailed because you want to track the activities. You want to track the progress of the project. Okay, we already have talked about direct and indirect costs. So indirect costs were the overheads, right? So direct cost is labor. So labor cost is calculated how many labor hours you need multiplied by the rate per hour they are charging you. And this rate can be different according to their skill, according to the productivity, and according to the overtime. So labor, when they are working in normal hours, their charge is less. When you keep them working for overtime charges are higher. Per hour charge for normal time would be, if it is 10 BD, then overtime could be 12 BD per hour. Okay. Skill level, obviously, foreman, 8 hours working of foreman and 8 hours working for a person who is just lifting or transferring the material. Okay, the foreman will charge you more, obviously. Okay, and then productivity. So you are hiring the same people who can do everything on the site. Okay, so their productivity could be less. But let's say you are hiring specialists for steel work. So since they are specialists, they are supposed to do the work faster. Okay, and then they can charge you higher as well. In the previous lectures, we already talked about how you will calculate the number of people you need on the site. Okay, so based upon that, you can multiply with wage rate and calculate the labor cost. Material quantity, very easy. Yeah, the quantity of the material multiplied by the unit cost of the material, and depends upon fluctuation in the market. Okay, obviously that's very simple, logical. And wastage. Okay, so construction job by nature includes a lot of wastage of material. So the concrete which is prepared is not 100% consumed. Okay, a large or a significant quantity of the concrete is wasted. Okay, some of it gets stuck in the mixer, some of it drops while you are transporting it, some of it is used for testing. Okay, some sites may require many tests. Okay, so it could be test for even only cement and aggregates separately. So obviously this is also material, right? And there could be tests for the mixed concrete as well. So this is also obviously the material which you are not using on the site itself. Okay, you talk about steel, so you have to cut the steel into required sizes. So there could be small pieces of steel which are not used at all. Okay, when you're using the formwork, especially the wooden formwork, it gets damaged when you are fixing it and then removing it. Okay, so some of the formwork would be wasted. Okay, and transportation cost, usually around 10 to 20%, around 20% of the cost is for transportation. Okay, so this is very important. Then you have the equipment cost, we already talked about it, and it depends upon whether you are owning the equipment or renting the equipment. It includes usually depreciation, fuel and maintenance. We have already talked about all of them. Then we have indirect costs, including overheads, utilities, connections, subscriptions, and so on and so forth. Some permits you may have to take. You have to take the approval from the ministry. You may have to take approval from the traffic department. You may have to take the approval from whichever body authority you have. Okay, and insurance. Okay, you have the worker insurance, you have the car insurance, you have the equipment insurance, and then there are insurance for the complete projects as well. Okay, the construction projects are normally insured Okay, most of the cases the projects are insured. Obviously, for insurance you have to you have to pay the fee and so on and so forth. And it is usually the overheads are usually 10 to 20% of the direct cost. Okay, so we may not calculate the overheads in detail like we do for the direct costs. Direct costs are usually more detailed, more accurate. Indirect costs and contingencies are usually just added as percentages. Okay, so you can see the percentages here. So the main thing is the direct cost here. So contingency I already explained, any unforeseen event which may or may not happen. So you put an extra cost if this thing happens, and then you have the profit margin. Profit margin 8 to 15%, very low, right? Only 50% or something, right? So, but these things again are just added as percentages. So the costs can be estimated as unit costs. Okay, you have a unit cost based on the quantity of the job. Okay, so per unit this much. Okay, uh, per unit of material, per unit of labor. Then you multiply with the rate with the quantity or the thing which you are using. You can have cost per task, so per cubic meter of concrete. So concreting is a task, right? And the material in concrete will be used for the unit cost. So in the first one, I am saying, okay, I will calculate unit cost for the cement and the aggregate and so on and so forth. But in the second one, I am focusing on the task. What is the task? Concreting. Okay, so I know concreting involves cement and water and aggregate and formwork and labor. All of it will be put as unit cost for the concrete itself. Okay, and this is used for tasks which are repetitive. We have talked about this in type of contracts. Okay, so we have 20 foundations. We will not go on the detail of each and every foundation. Okay, per foundation this much, that's it. So it's a simple and fast method. Okay, so an example is given here. The labor is costing you $30 per hour. You need 50 hours of the labor. So 30 into 50, 1,500. Then you have the material cost, which is for 100 units, it will cost you $2,000. So per unit is 2,000 upon 100. Okay, it's 20 per unit. Okay, so total cost will be labor plus material. If you are only using these two, then you can add other things as well, equipment and so on, if you are using it. Okay, another method of calculating the cost is using production function or assembly cost method. Okay, so in this method you are considering the cost of the entire project or the entire system. Okay, system if you are talking about industry or something. So we are not looking at individual units, we are looking at the overall project. Okay, so in the unit cost I have to look at individual activities because unit cost for each activity will be different. When the production function assembly cost method, we are not looking at individual units, we are looking at the entire project as a whole, and then we have to look for the total cost. So it can involve labor, material overhead and everything. Okay, and it is used for more complex or unique construction cost tasks such as HVAC systems or plumbing and industrial projects and so on and so forth. So in this case you are basically looking at how many resources you will need for the output you are looking for. So for example, how many labor hours you will need for every square meter of the work you complete. Okay, so this can be, for example, if you are doing the wall, let's say, so every square meter of the wall has item for framing, drywall, batching, painting. Okay, so the complete cost is combined, and then you look at, okay, every square meter of material or every square meter of wall will require this much labor and so on. Okay, so they are generally done for assembly based tasks. Okay, like for example, cutting of steel, let's say uh, if you are doing precast slabs or something, so these are assembly based tasks. Okay, tasks which are done in enclosed environment, uh, repetitive but not on site. Assembly based tasks are you are doing it somewhere separate and you are producing that product and you are bringing it to the site. Okay, it requires more detailed project data and it can be time consuming. For example, for HVAC work, you have $50 per hour and you need 100 hours for the labor. So 50 into 100 gives you $5,000. Then you have material cost, which is you have cost for the equipment, which is $15,000, and overheads is 2,000. So in the previous case, unit cost, the overhead was not included. If you see here, overhead is not included. Here the overhead is included. So some part of the project overhead goes to this activity as well. So total cost will be this much. Okay, so you are distributing the cost of the project into the activities as well. Okay, so you are no longer taking the percentage in the end. You are incorporating it within each activity. Okay, overhead, contingency, profit, everything is included in each activity as well. Then we have the uh, other approach, which is called as empirical cost inference or parametric estimating. So in which you are using previous data, okay, or you are trying to estimate the cost of the project based upon the parameters of the, so that's why we call it parametric. Okay, so I am trying to calculate the cost of the project using the parameters of the project. Okay, so for example, if you look at the examples given here, I'm going to build a project which is a building project. Okay, so I looked at the projects in the past. Okay, so I looked at a building which was very similar to my building, and that building had an area of 50,000 square feet and had a total cost of 22 million. So what was the cost per square feet? 40. Okay, now for my project, my size is 60,000 square feet. So per square feet is 40 multiplied by 60,000. So this will give me the total cost 2.4 million. Okay, so this is coming from the previous project. Okay, this is coming from the previous project. The previous project was costing me this much, any previous project. Okay, so you are relying on the historical data, and for your project you are just using some basic parameters. Okay, so from the historical you take an average rate and then you multiply this average rate with the parameter of your project. This is the cost inference, empirical cost inference method, or the parametric estimating method. This is what we can use as the conceptual stage. So you can see I don't need any detailed design here. Okay, so this is at the conceptual stage. Okay, so you can use it if you can find similar projects, obviously. So I'm going to build a state-of-the-art exhibition, what do you call exhibition mall or exhibition theater, which is not available in Bahrain. I'm going to have like 3D facilities there, and I'm going to have best of the facilities there. So if the project is not available, example is not available in Bahrain, then this type of thing is very difficult to be done. Okay, so we need something which is very relevant to do this type of an estimate. But if you can find this a similar project, then the work is very easy. You can see just okay, total cost, total size. You have the rate, multiply by your size. So this is very fast and usually reliable if you find historical data which is relevant. Okay, now if you look at the example, they have done it with one project only. This is not a good method to calculate the cost of the entire project using just one example. So the historical data is usually taken for multiple projects, so we can have an average. Okay, so that's where it becomes more difficult then, because now you need like 10 projects which are similar to mine, and I need their size and I need their cost, and I need to calculate an average. Okay, and then you may have made some assumptions as well. Okay, that you may say, okay, in my project I'm going to use the same air conditioning system which they are using, but that one is old. You go into the market, you don't find it. Okay, so these are the types of assumptions you are making. Okay, so whenever you are using historical data, there are some assumptions, because those people did their work in a different way. So you are assuming I will do it in the same way and this will work for me. This may not work for you. Okay, so I'll stop here.